go ahead and talk about one-to-one functions and their inverses. So the thing about functions is that they take a value x and they take that value and it goes into the function, and then out comes a value f of x. Okay, now the inverse would be to reverse the process. So if you put an x in and you come up with some value here, can you take this value and figure and return it back to the original value? Okay, so the inverse function would take that value x and would take this value f of x and return x back. Okay, so we can write that by, we can express this with this equation right here. So f inverse of f of x is equal to x. So you start out with x, f takes it to some value, and then f inverse restores the original value. Okay, now also what's going to happen is typically is you'll have this thing going on as well. So if you start with x and you apply f inverse to it first, and then f will take it back to the original. Okay, but either way, it's just reversing the process. Now, in order for this to work, okay, so this one-to-one part right here, in order for f to have an inverse, it needs to be one-to-one. Now let me just briefly go to the next page really quickly and explain what it is. One-to-one means this right here. A function is one-to-one if different inputs produce different outputs. You can tell from the graph of a function that it's one-to-one by using this time it's the horizontal line test. Okay. So different inputs lead to different outputs. That's what one-to-one means. You can tell it by using the horizontal line test. That means the horizontal line is not going to intersect in more than one place. Okay, if that's true, then the function is one-to-one. Okay. Now, so because what happens is, let's take a function that's not one-to-one. Like let's say, to try to illustrate this point right here, if we take f of x equals x squared, we know that f of 2 is 4, right? But f of negative 2 is also 4. Okay, so if we have a 4 and we want to go back, then and we want to, so if we have, so right here, so we put a, so like for example, so what this would be like putting a 2 in, you get a 4 back. But when you're at this point, you don't know what the original one was, but the inverse is supposed to give you back the original one. But if it's a 4, you don't know whether it's 2 or whether it came from a negative 2. You don't know where that 4 came from. You don't know where that 4 came from. In this case, it came from a 2, but it could have come from a negative 2. So you don't know you don't know how to get back to, you can't definitely get back to the original. Okay, and as far as the horizontal line test, x squared looks like this, and here's those two values right here, and a horizontal line intersects both. So that violates the horizontal line test. Okay, so let's move along to more exciting exercises. Number 2, for a function to have an inverse, it must be one-to-one, which is what we discussed on the front page. So which of these following has it? This one has an inverse. This one doesn't, because it's x squared. We talked about x squared not having an inverse. But x cubed x cubed, the graph looks like this. And so horizontal line doesn't intersect in any places. Now to find the inverse of a function, what you can do, what is a function? So take this guy right here, set, make it y equals x cubed. To find the inverse, we change, so we change the f of x or whatever, or in this case, the g of x to a y. Okay, the next step is we're going to solve for x. Okay, so if we take cube roots of both sides, then we get this, or x is equal to the cube root of y. Okay, so that's solving for x. And then the next step, the final step would be to rewrite this as an x, but then to change this to an x, and then rewrite g inverse of x equals the cube root of x. Okay, so right here we have the cube root of x. Okay, now this one right here, you can get this right here by going into functions on the menu, on the Webassign menu. And then you'll see like you'll see a thing like this with a little box here and a box right there. And that's when you choose. You put a 3 in this box and an x in the other box, and that's good. Okay, so sometimes you can figure out the inverse, f inverse, from this verbal description. Okay, so here you have a function, multiply by x, add 8, and then take the 5th power of the result. Okay, so to reverse those, or to reverse that process, you start with what was done last and reverse it first. So taking the 5th power, the reverse of that is taking the 5th root. So that would be a 5th root. Then you want to reverse this, so it's have to subtract 8. And then you want to reverse this one, so you divide by 6. Okay, now f of x, so looking at all this, so I like to think of this as like a bedtime story. Once upon a time there was an x. It was multiplied by 6. So once upon a time there was an x. It was multiplied by 6. And then 8 was added. And then it was the 5th power of the result was taken. Okay, so that's going to be this. Okay, and then for the inverse, you can say, meanwhile, in the antimatter universe, there was an x, and the 5th root was taken of it, so that's the 5th root of x. And then 8 was subtracted from that, and then it was all divided by 6. So it's all divided by 6 like that. So this would be 5th root of x minus 8, all divided by 6. Okay, let's go to the next exercise. A graph of a function f is given. Okay, does it have an inverse? Okay, so here, any place that you draw a horizontal line only intersects in one place. So yes, it has an inverse. Okay, now the thing about inverses is that in the graph of f and the graph of the inverse is that if a and b is on the graph of y equals f of x, then if you reverse those, b comma a is on the graph of the inverse function. Okay, because this means that f of a is equal to b. But in order for, but the inverse property says that if f of a is equal to b, then f of b, then the inverse of f of b is equal to a. So b would restore. So f inverse restores b back to a. Okay, so we want to find f inverse of -1. So what you do is you look here for -1 here, and that's going to be 2. So f of 2 is -1. Okay. Okay, so that's because f of 2 is -1. Okay, and then for the second part, you look for 7. 1, 2, 3, 4. So 7. You look for 7 here. Go across. Come down. 1, 2, 3, 4, 5, 6, 7. That's 8. So that's going to be 8 is the answer. Okay, and that's because f of 8 is 7. Okay. Okay, number 5. This goes to back what I just said before. If 1, 7 is on the graph of that, then 7, 1 is on the graph of the inverse. Number 6. This notation here is kind of confusing because this is false. It's not always the same as 1 over f of x. Okay, so it's confusing notation, I will admit, because when you see, like, let's say you have like 5 to the -1, for sure that's 1 over 5, right? If you have any number here, a to the -1, that's just going to be 1 over a, where a is any real number except 0. Okay, that's going to be true for that. But the inverse means something else. When you have it with a function, it means something else. It's not this. Okay. What it is this right here. What it is right there. That's what that means. It doesn't mean 1 over. Although for numbers, you still have to remember that if it's a number, any number, or even if it's a variable, x to the -1, that's 1 over x. But if it's an f to the -1, which is a function, then it's not 1 over the function. Okay. So that's kind of confusing, but we'll just have to live with that. Okay, so number 7. This satisfies the horizontal line test, right? Because the horizontal line doesn't intersect in more than one place, so this is 1-to-1. Number 8. This is not 1-to-1 because if you have a horizontal line right here, it intersects in lots of points. And all you needed to do is intersect in more than one point, and for it to not to be a 1-to-1 function. Okay, so here we have number 9. We got f of x equals 6x minus 7. Now this is a line. What the? Come on. Oops. Okay, so this is my drawing thing decided just to go wacko. Okay, so this is a line. The y-intercept is 7. The slope is 6. So it's going to be like that, a steep line like that, and it's going to satisfy the horizontal line test. So the answer is it is 1-to-1. Okay. Number 9. Okay, this is going to be a parabola that opens up. So it won't satisfy the horizontal line test. So this is not one-to-one. Okay, now this next one, t to the 6th minus 6. What happens there is that is, so t to the 6th is like this really flat thing, but this is shifted down by 6. So it's going to be this flat thing that then just shoots up like that, kind of relatively flat. It's not completely flat. Not completely flat here because it's because from here on over it slopes up ever so slightly, but then it starts going really steep right there. Okay, so normally if it was just this would not be one-to-one because it violates the horizontal line test. But this piece right here means that you're only looking from 0 to 7. Okay, so you're only looking at this part, well, up to a certain point. Okay, up to maybe here, we'll say. And then it's cut, so only from there to there, which means that this part's all gone. It doesn't exist, and because of this piece here, you're only restricting it to there. So that means that it is one-to-one. Okay, it would be kind of like this one right here. It's not one-to-one, but if you were to restrict it to just this piece here, it would be one-to-one. If you were to throw all that out, which is essentially what they did with this statement here. So 11 is one-to-one. Okay, number 12. Here, again, f of 6 is 17. So 17 inverse, the inverse needs to return 17 to 6. And if the inverse is 40 of 86 is 43, then 40, that means that 43, that f took 43 to 86. Okay, here's another exercise. If g of x is x squared plus 6x, with x greater than or equal to -3, find g inverse of 40. So again, just this part right here, if it was just this piece, then this would not be one-to-one. It would not have an inverse. But with this restriction, apparently it does have an inverse. And you want to find g inverse of 40. One way you could do this is like we did before. You could say y equals x squared plus 6x, solve for x, and so on. And then rewrite it as g inverse, okay? You could go that route, but there's an easier way to do this one, and that would be to take g of x and set it equal to 40, okay, and find what values of x that gives you, okay? Okay, so this factors, so I bring the 40 over here, this factors. 40 factors into 4 and 10. So plus 10 and minus 4 work. And then setting each of those equal to 0, there's a 4, and this gives you a -10. Now, but they have this condition here that x has to be greater than or equal to -3, which means that we throw that one out, and it has to be this one. Okay, so the answer would be 4. Okay, let's look at number 14. This is F. So when you see these graphs, it's important to recognize that this is the graph of F, because sometimes they can be tricky and give you the graph of y equals F inverse of X. Okay. Okay. So here you want to find F inverse of 1. So again, you go to where y is 1, and this comes over to here. This is 7. So the answer to that is 7. Here it's F inverse of 4. So you come over here to 4 here and over here, and that's going to be 4. And then F inverse of 5. So you come over here to 5, and that comes over to there. That's 2. That's 2. Okay, and again, this is because F of 2 is 5. That's why this, 2 comma 5 is on the graph, because F of 2 is 5. And F inverse restores the 5 back to what it to 2. Okay, number 15. It's the same thing with the table. So for this 0, you come over here and you look at this one. And the answer there is going to be 3. Okay, that's because F of 3 is 0. Okay, so the inverse will return 0 back to 3. Number 6. Okay, number 6 is a little bit tricky because it's F of F inverse of 6. So it's not just F inverse of 6. This is actually going to be 6 in general without even looking at the table. You can kind of guess what that is, but let's look at the table. Okay, so F inverse of 6. We calculate the innermost one first. So here's 6. That's going to be 5. Okay, but F of F inverse of 6 will be F of 5, which will put us back to 6. Okay, so that's going to be 6 right there. Okay, number 17. Determine whether these are inverses of each other. So to do that, the easiest way is to take F of G of X to calculate that. And the way that you can tell is if this is X, then yes, they're inverses of each other. Okay. But if not, then no. Okay, so if this is X, then they're inverses of each other. If this is something else, then they're not inverses of each other. Okay. So we can go ahead and calculate that. F of G of X. So G of X is this. It's X minus 7 over 6. Okay, now we're going to plug it into here. So this X has been replaced with all that. So that means we're going to replace that X with all of this. And then you have this plus 7 right there. And then everything just kind of cancels out because those 6's cancel, so we get X minus 7 plus 7. We have a minus 7 or plus 7. So those reduce to 0 and you end up with just X, which, so we're in this situation. So the answer is yes. Come on. Okay, hold on a second. My thing decided to go wacko again. Okay, so the answer is yes. Yes, they are inverses of each other. Okay. Number 18, determine whether these are inverses of each other. So we do the same thing here. f of g of x, that would be f of, just replace this g of x with 1 over x plus 7. Okay, and then you put this 1 over x right here. Okay, so all of this replaces this x right there, and I get this. So this, you have the 1 here, you got the minus 7 there. Everything else is the same. Okay, I can just remove those parentheses, and these guys cancel. So we have 1 over x, but that's the same as x. So yes, they're inverses of each other. Okay, number 19. Here you're getting into, again, how to find inverses. So let's go through the steps. Replace the f with a y. Okay, so replace. Okay, and then the next one is you're gonna solve for x. This is what the book tells you to do. So I'm gonna bring this 7x over here, bring the y over there, like that. Divide everything by 7. That's all over 7. Okay, so that's this part here, and then finally replace the x with f inverse of x, and replace the y with an x, and there you go. Okay, so that's going to be the answer right there. Okay, so this right here is this one, and this right here is this one. Just replacing those back. Okay, let's look at, here's a little bit harder problem, but this is a technique that I want you guys need to know. So this is finding the inverse function. So we follow the same steps, replace the f of x with a y. Now the next step is to try to solve for x. Now the problem is there's 2 x's here, right? So that's going to be a little bit harder. But we'll multiply both sides by x plus 6. So we get there. Then we'll distribute this y in. So xy plus 6y equals x. Okay, really important here. What we're going to do here is we're trying to solve for x, right? That's our objective. We're trying to solve for x. We have an x there, and we have an x there. Get all terms with x on the left and all others on the right. Okay, so that's what I'm going to do. So this x, this x is going to come over there to the left. This term is going to go over there. Okay, so that's going to give me xy minus x equals negative 6y. Okay, 6y went over here. This x went over here. Okay, now I'm going to factor an x out. Okay, so factor out an x. And then I just divide by this. And then it comes to the last part where we replace the x with an f inverse of x and replace all y's with x's. Okay, so replacing these y's with x's and replacing the x with f inverse of x. Okay, and then and this will be the answer right here. F inverse will be negative 6x over x minus 1. Okay, same kind of concept here. Replace the f of x with a y. We have x is greater than or equal to 0. So now I want to solve for x, bring this over here, bring the y over there. Extract square roots. You have a plus or minus. That's a problem, having a plus or minus. But this piece here resolves that, and it has to be a plus. It has to be a plus because this, okay? And so now we replace, again, we replace the x with an f inverse of x and replace the y with an x. Okay, so this x got replaced with f inverse of x, and the y got replaced with x. Okay, number 22. Find the inverse function of this. So this is, again, replace the f of x with a y. Okay, now we're going to square both sides. And solve for x. Okay, so this goes to the other side, that goes over there. Extract square roots, and you have plus or minus the square root of 25 minus y squared. Again, right here, x has to be positive because of this, which means that this one has to be positive. Okay? So we can complete the last step, which is to replace this x with an f inverse of x and replace the y with an x. Okay, so this will be the answer. Okay, so number 23 was use the graph of f to sketch the graph of f inverse. So the graph of f inverse. Okay, so the easiest thing to do here is you've got these points right here. Okay, so we identify what those points are. So this is negative 10, comma, negative 6, right? So the negative 6 is right here. So that means that negative 6, comma, negative 10 will be on the graph of f inverse. So if we go to negative 6, negative 10, that's this point right here. Okay. Likewise, this point right here, this is negative 2, negative 1. That means this point here, negative 1, negative 2 will be on the graph. Okay, so in Webassign, I'm not going to do it in Webassign. I'm just going to explain how to do it. Select the line segment tool and then draw a line segment between these 2 points. Oops. Okay, with the line segment tool. Between those 2 points. And make sure that you're including both endpoints. Okay, then the next one is this point here. This is 6, comma 5. Okay, and so that means that 5, comma 6, which is right here, will be on the graph. So you draw a line segment between these 2 points on Webassign. They'll intersect right here, by the way, but that doesn't matter. Just focus on those 2 points, negative 1, negative 2, and 5, 6. And then finally, this point is, this is 10 and that's 9. So this is 10, 9. So that means that the point 9, 10 will be, which is right here, will be the on the graph of the inverse. So draw a third line segment between 5, 6 and 9, 10. And that will be the inverse. Okay, so basically, you're going to do 3 line segments, including the endpoints.